So hi again and welcome in the Global Research Stream session. So in this session, you will hear about various research topics, including various models. But before to start, I really would like to take some time to focus, to focus on the workflows, and especially the ones that have been used to generate realistic landscape evolution models that Kian, Sue, or Chris used, for example. To do Earth's realistic surface evolution model, the first step is to build the topography. To do that, we use a backward step. So here, to obtain a paleotopography 30 million years ago, what you do is you take the Earth's topography, here the e-topo raster, you remove the dynamic topography impact or the tectonic impact, remove the sediments from the margin here of the South African margin, and add the deflection back. So now, when we apply this workflow to rift events or when we go back in time, it becomes a little bit more complex as we need to incorporate horizontal displacement. So here, in order to have an initial topography, we do the same thing. We take the actual Earth topography and then we remove vertical displacement, but also horizontal displacement. And we do that in order to match the paleotopography or the information we have in the bibliography. So when it's matched, then we use this initial topography, put the vertical horizontal displacement back, include sea level, precipitation, etc., etc. And we do another work in order to match the, for Sue here in the Norwegian project meant with Equinor, it was to match the palic surface or to match the actual topography and also to match the sedimentation. So here are some tools we use to determine when a model is realistic enough to be used. So here's an example of Chris Niles Delta project. You have a model topography and the e-topo topography. And when you compare the two, Chris area is here, and you can see that the variation between the Earth topography and the model topography is really low. You have other tools. You can use catchment geometry, location and thickness of deposits, sediment volumes, etc., etc. Now, the first application for this workflow is my South African project. So together with Tristan, we wanted to answer this question. Is the dynamic topography impacting the sediment flux in the South African region over the last 30 million years? And we wanted to answer this question because scientists disagree on the timing and the driver of the South African uplift. Several arguing that it's due to dynamic topography. So what I've done is I tested 4 different dynamic topography scenarios varying by the mantle flow calculation and the wavelength. So here you can see the changes in dynamic topography through time and the value for the 4 different models. So what I obtained is this different model. So here you have the elevation 30 million years ago and the present day elevation here. And here the difference between the Earth's topography and the model topography at 0 million years. And you can see that, well, we can easily compare this data. We don't obtain crazy things. So once we have done this comparison plus sediment flux, sediment volumes, etc., we can really look at the flux and the impact of dynamic topography. So here you have the 4 dynamic topography models with rainfall maps. And here you have the 4 landscape evolution with dynamic topography model with fixed rainfall map. And here are the Earth sediment flux calculated by Baby et al. What you can see here, well, you have the river capture here during these peaks, but you can see that the climate impact, when we have it or not, is quite impressive. But when we talk about dynamic topography impact, it's way less obvious. The same thing with catchment basin. So here you have different catchment here depending on the time, 30 to 0 million years, but it's clearly not evolving through time. So in order to look at the major impact, we looked at the Pearson coefficient with correlation coefficient that we have between rainfall, dynamic topography, and instantaneous erosion here. And what we have is clearly the correlation, the best correlation between erosion is the climate. So basically what we discovered is that the drainage geometry and river location of the orange catchment didn't change through time. And none of the tested dynamic topography scenario allowed to generate the same rate of sediment flux that's what we observe. So the pulse of sediment flux can be induced by climate. So just one thing, careful, I'm not saying dynamic topography doesn't impact landscape evolution. I'm saying for South Africa for the last 30 million years, it looks like it's the case. So if you have any question,